In the previous video, we looked at the different factors and properties that affect the gas pressure. And if you remember, we talked about the size of the container, the number of the molecules of the gas inside, as well as their average kinetic energy. So basically, when you increase the number of gas particles inside, how does that change the pressure when you increase or decrease the volume of the container? And here it's a two-dimensional box, so I guess the area of the box, but now we live in a 3D world. So when you have gas inside of some kind of a bag, when you decrease the volume of the bag or increase its volume, how does that change the pressure inside? As well as when the gas molecules are moving faster or slower. One could also ask the question, how about the type of a gas that I have inside? So if I have oxygen gas at particular, there's a particular volume, a particular temperature, a particular number of molecules. So let's say if I put 50 oxygen molecules inside, what the pressure is compared to if I put 50 nitrogen molecules or some molecules of another gas. So the volume is keeping the same. We're keeping the same volume. We're keeping the same temperature, and we're keeping the same number of molecules, but we're changing the type of the gas. And the question is, does that change the pressure of the gas? So is there a relationship, or does the type of a gas affect the pressure? I thought we could test this with the PHET simulation and see how the programmers of the simulation, whether they did anything, whether they incorporated it into their program. So this is not showing the real thing, but still we can use it. We can ask ourselves this question, and let's see how the PHET simulation reflects this. So I put in 50 molecules of some light gas. We don't know what gas it is, and I'm keeping the volume at the default setting, as well as the temperature. I didn't do anything. I didn't add any heat or reduce any heat. With 50 light molecules, I'm getting, you can see that the pressure gauge, and the pressure gauge goes up and down. So it's between, there's a certain range of the pressures, because really with this number of molecules inside, at any given moment, or the number of collisions at any given moment slightly changes, because there are moments when probably there's a particular instant of time when none of the molecules are actually hitting the sides of the container, and so the pressure changes slightly. So I can see that it goes, right now it says 0.24, 0.25, going back and forth between these two values. Now it's 0.26, there was a moment for 0.27, 0.23. So I'm going to write down from about 0.23 to about 0.27 atmospheres. I also want to, now it was 0.022, so I'll put it down to 0.22. I want to bring your attention also to the fact that for some reason, I don't know why, in this PHET simulation, once you put a certain number of molecules of the gas inside, with time the number of molecules decreases. It seems like the molecules are somehow mysteriously escaping through the walls of the container. And I don't know whether the programmers did this on purpose to simulate sort of what is happening in nature, or whether there's some kind of a glitch in the program. But I have noticed before when I blow a balloon for my little son, and he leaves it, so he plays with it, and then he gets bored. The next day, the balloon is deflated, and I wonder whether the gas molecules escape through the actual sides of the balloon, or whether they escape through the through the hole that I blew the gas in. And of course I tie it, but maybe through this little tiny crack, some of the gas molecules can escape through there. Anyway, so in this simulation, for some reason, some of the molecules escape mysteriously. So right now I put in 50, but I know that after some time, if I look at it, it's going to say 49, for example, or 48. Anyway, so we have again, the pressure is somewhere between 0.22 to 0.27 atmosphere at this moment. So we could express this as about 0.2, what would it be? Let's say 0.24 plus or minus 0.03 atmosphere. So 0.24 on average plus or minus 0.03 gives us about the pressure that we see right now. So let's change the gas. Let's reset this, and let's change the gas to these heavy species of gas, and the same number of molecules, 50. Again, we don't know what type of gas this is, or which particular gas this is. We just have 50 molecules of a different type of a gas. We'll let this to settle down a little bit, and then at the end we're going to change this so we have 25 light and 25 heavy. Right now I can see that it actually went slightly further than what we had before. Right now it's 0.24. Sorry about that. 0.28, 0.27, 0.25, 0.26, 0.25, going up and down between 0.24 and 0.25, 0.26, 0.27, there was a 0.28, 0.29, let's say 50, we have 50 of them inside, 0.25, 0.26, 0.27, 0.28, 0.29 again, 0.3, there was a 0.3 there, 0.24, 0.23. It seems like the smallest one that I saw was 0.23, and it went up all the way to 0.3. So on average, it looks like we could express this pressure with 0.27, about 0.27 plus or minus 0.03 atmosphere. So previously we had 0.24. Right now we have, or it's showing 0.27. The uncertainty in both of them about plus or minus 0.03 atmosphere. So the values are slightly different. It seems like with these heavier species of gas, we have slightly more pressure. And again, we don't know whether this is something that the programmers did on purpose. And again, basing this on just one trial is not really good science. We should do this more than once, and to see whether we get the same results again. That's of course your job to do. I'm just sort of talking in here and expressing my thoughts. So let's reset this again, and let's now put in 25 heavy species and 25 light species, light gas molecules. So again, we have the same number of molecules inside. I haven't checked the temperature previously. Now it's showing 300 kelvins. I think it was 300 previously as well. Again, we didn't change the size of the container, and we didn't apply any heat or ice. So the kinetic energy of these molecules is at the default settings. We just changed the type of the molecules inside. In all three cases we had 50. First 50 light, then 50 heavy. Now we have mixed 25 heavy, 25 light. So what are the values doing? 0.27, 0.28, going back and forth, 0.26, there was 0.29, 0.3. The top one so far was 0.3, the bottom one was 0.26, 0.25. I didn't see it yet go below 0.25. So it seems like the range is from 0.25 to 0.30, which, if you remember previously, oh, now it was 0.24, now it's 0.23, 0.22. Did any of them escape? Oh, you can see now one of the light molecules somehow mysteriously escaped. There were 25, now it says 24. So let's put it back inside. See, I don't know why this is this glitch. Is it a glitch in the program, or is this done on purpose that one of the molecules somehow escaped? But even with those 25, I saw it now go 0.22 again. So the smallest value that I saw was 0.22 atmosphere. So let's change this to 0.22 to 0.30, which on average now would give us about what, 0.26 plus or minus 0.04 atmospheres. So the three values that we had. Let me turn this on. Don't save. So the three values we had 0.24. Sorry for my weak writing with the mouse. Plus or minus 0.03 atmospheres, and this was, I believe, this was with the light species, light gas. Then we changed the gas to heavy gas, some heavy large molecules, and we got 0.27 plus or minus 0.03 atmospheres. And the last one we got was 0.26 atmospheres plus or minus 0.04 atmospheres. So what do you think? Does a type of a gas affect gas pressure? Is this what we did here enough to be able to, in a way, to state a conclusive answer to that question? I'll let you answer that, and I'm looking forward to hearing what you have to think about this and what you find out.